as you all are coming in to join us for getting started about engineering. My name is Ray D'Agostine. I'm a professor in chemical engineering and one of the lecturers for engineering, technology, and society. And literally on my screen, to my right, is Associate Professor Gavin Buskus, who is the first year coordinator for all our engineering programs and also the course coordinator for engineering, modeling, and design, which is offered in semester 2. But what we want to do today is share with you a couple things about engineering, technology, and society, a couple just kind of brief overview things, and kind of think of it as a movie trailer for the first lecture. And also, we're going to go, how on earth do I get to the first lecture in our online environments, and where do I go, and what do I need to click on to make sure I can make my first lecture? And if I can't, is it lecture captured? How can I find out that information? So by the end of today, you'll walk away knowing at least that, if anything else. Plus, you might have an idea that my accent's different than Gavin's, and we both think we're funny, but in different ways. With that, I'm going to share my screen, and hopefully on my new at-home setup, that'll work. So in the chat, if anybody, can you guys see a PowerPoint presentation just not open? So feel free to say, oh, thank you. Huh, that makes me feel much better. Let me just kick it into a slideshow. Now, if you feel like registering today for the event, I just put that link in the, that's probably better because now we can actually see. I just threw that link in the chat. You don't have to register. They're going to see in the participants how many people showed up, but that's just science's way of trying to find out how many people actually came to the session and ideally found it useful. So let's talk a little bit about engineering, technology, and society. So this is the first subject engineering offers to everyone in your first semester at university. And so we'll just move that out of the way. ETS is, I'm going to close the, actually, I'm just going to move the chat off screen. So ETS is, it's our first chance to introduce you guys to what engineering is. And so you could say the world of engineering, but really what we're trying to do is show you how engineers, the role as engineers play in society. And also specifically, you know, start to tease at the idea of how is engineering different than science. And part of that is also how we use technology, but it's also how we tend to focus on solving societal challenges. And that motivates us, even if we get very technical and we get excited about a very technical point, it's normally in a problem in that larger context. So we can't cover all of engineering in one subject. Oh my goodness. I mean, there's like 7 or 8 basic branches of engineering, and there's 6 engineering departments, so plus computer science. So it's a lot to squeeze into one subject in semester 1 and semester 2. So what we've done is we've broken it up into 4 modules but we've done that because we have this cool semester-long design project on designing a renewable pumping system to deliver safe drinking water to a remote community. And so there's a project that helps us pick what parts, the little technical pieces of what technical pieces we're going to dive into for engineering to go through them. Now, that's kind of the subject in a nutshell. I promise it'll be different than any of your lecture subjects because we have workshops, you get to work in teams. It's very applied problems in engineering from the start. Excuse me, but I will go through a few details. This is snapshots that I don't think any of us are proud of for the teaching staff, where there's myself, Lionel Lamb, who's a chemical engineer that works in biomedical engineering, and Lee Johnson, who is a computer scientist and an electrical engineer working as a biomedical engineer. She does some really cool stuff. And Yui Chan, who is our workshop coordinator, who's also an electrical engineer by training, I think. And we're part of the teaching team that's there to try to see you succeed. There's that, and we have an army of demonstrators that work in our workshops, which are a set of really exceptional, high-performing students that are in engineering on the master's or PhD level that are really interested in seeing students get excited about engineering. And so there's a whole group of us that are there to try to make sure you have an engaging experience. So our design project, I'll promise, don't worry about if you go, what is that schematic? I don't know what it means. That's okay. We're going to go over all this in the first lecture, but really it's about the idea of taking water from one place, in this case, a storage tank, pumping it, disinfecting it with ozone, actually making sure that it's clean, and then distributing it. And the reason why we focus on water, aside from the fact that there are aspects of this that link to every engineering you could think of, is that a third of the water does not have access to safe drinking water. And this problem is going to be something that I guarantee out of the engineers graduating from Melbourne Uni or starting this year, a significant fraction of them are going to be involved in delivering water to society in some way. It may not be as direct as you think. Might not be treating water. You could be building a sensor to manage irrigation, but engineers will be involved in water as part of your career. So we think it's a good starting point. Now, I said we're in modules, and don't worry, all of this information is already on Canvas. These slides are actually already there, and I will show you where in a second. But this just kind of shows, I mentioned our subject is broken up into modules. And so they're kind of broken up, and the yellow is general how engineers think, engineers' problems in society, and stuff around running the course and being at university. And then you see we have 3 color-coded blocks about fluid mechanics, about water treatment, and about online sensing and image processing, because those things all fit in your design project. Again, this is like the movie trailer, so don't worry if you can't read all of this. But what we have is that every week we have a lecture, and you'll see there's 3 lectures a week. And then you'll see there's a workshop stream where what you learn in lecture 1 week, you actually apply in your workshop the next week. So it's time to learn about it, and then the next week use it. And that's actually how we structured the whole subject. Now, as I said, the first engineering module is about trying to understand what engineering disciplines are, how we solve problems. We're going to talk about communications and teamwork skills, but we're also going to talk about the different types of engineering as well. So I'm not going to say what engineering I think goes with each one of those figures, but obviously I will in the first week of lecture, but have a look and go, which engineering is that? And I realized I did not put the better electrical engineering picture in, which Gavin might have. I did in the lecture, Gavin, so it does look better. As I mentioned, there's modules there. And again, all this information's on Canvas. Don't worry if you're not following it all now. It's not too much the point, but we'll have bits on engineering society. We're going to understand how water moves through pipes and how pumps work, because you'd be surprised just how many types of engineers care about that. We're going to talk about what you actually need to do to make water treatment safe, but don't worry, we're not going to like put you in lab and make you try to disinfect water and then test that by drinking it. That would be cruel, but you're going to learn how those things work. And then we're going to talk about how you tell if water is clean, or in this case, doesn't have particles, by using online real-time sensors, and in this case, images. Now, let's talk about some nuts and bolts, because I think in this lecture, people are kind of wondering about that, and I don't want to talk for too much longer. So lectures are all online, regardless of whether or not it's recorded or pre-recorded. Everything we do in lecture is also recorded and put on Canvas. So if you can't make the lecture, that's okay. Some people have time zone constraints or other constraints, but all our lectures are online. Sometimes you have clashes. In the first week, we're not going to have pre-recorded lectures. We're just going to have the lecture and then put it on lecture capture in Canvas. But for the rest of the time, we don't want to beat you over the head talking to you at Zoom. So we're going to have a mix of, you're going to have like a pre-recorded part of the lecture, and then when you come to the lecture time, it might be a little bit shorter, but we're going to work through an example together based on what you watched beforehand. So we're trying to make the part where we actually make you sit in Zoom be a bit more interactive. And also, those are going to be great times to ask questions. And that whole session will also be recorded in case you don't make it, and it'll be on lecture capture. Now, that's just one of the ways you can interact with us. Every Tuesday from week 2 on, we're going to have a 2-hour consultation session you can drop by, and all the lectures will set office hours. But all of these things are also recorded, and I will show you in a moment how to find the links to get to these lectures in Canvas. We have a workshop. Now, the workshop attendance is mandatory. You'll be working in teams of 4. This is where actually the fun part of the subject happens. This is where we're going to have an experimental rig. You're going to get to turn knobs and measure things and design things. And in each workshop, you're going to actually have something by the end of the workshop you have to deliver, a measurement, a plot, part of a design. It's mapped out pretty well, but it's a way that you're engaged for those 3 hours. Now, your workshops work on this experimental rig. This is our fluid recirculation rig. So it's got knobs and valves and things you have to read. You're going to actually replace components in here and test them. Then we're going to put a camera up there and do real-time image processing of particulate contamination. And I'd love to go into the details of this, but we're supposed to be doing the movie trailer. I mean, I could almost do music on this part. Actually, I have a video with music, but it was a little cheesy. But our workshops happen two ways. Some of them are virtual, not maybe 3 of them, where it actually happens online through Zoom. We put you in breakout rooms, you work as a team of 4, and we have a bit of structure. We just don't go do engineering for 3 hours. We have a part where you do things that look like tutorial problems. So based on the lectures, we have problem books, we have lots of practice problems, and you'll actually go through to do problems to make sure you understand things from the lectures. And then part B, which is the bigger fun, is the time you have to work. And this could be interactive videos on project-related tasks. And then at the end of that workshop, you'll have some type of deliverable that you have to actually have. Could be a plot, could be analysis, it could be, well, a lot of it's measurements and plots, or it could be a bit of MATLAB code, or it could be part of your design project, your actual final design. But that's our virtual workshops. And in 2020, we did all virtual workshops, but we are not doing all virtual workshops in 2021. We are doing workshops that are a dual model, in person and virtual. So it's the same structure, but when we do these project related tasks, well, we'll still be having Zoom open, we'll still have a breakout room, but some people will be physically in a workshop on campus and others will actually be remote, and you're going to work together. And so it's the same timetable, regardless of you're in person or online. So it's the same workshop time, but some of you are going to be on campus and some of you won't. If you are able to come to face-to-face classes, i.e. if you're in Melbourne, we're going to expect to see you there. But if you can't come to face-to-face classes, that's going to be integrated in. And the lecture is mic'd, and we've got Zoom cameras, and you're going to be in your breakout group. But really how that's going to work, because the first part, you're kind of working together on problems in your part A. And you can do that virtually and at home just as well. But the second part, all right, someone figured out the annotate part on clear all drawings. Someone realized that you can use annotate in Zoom, and all right, stop that. But you certainly can, unless my computer's having a problem I don't know about. So the workshops, some of them are in face, you can see, and some of them are, we don't have workshops in week 1, but some of them will be in person, some of them will be this mix. But how that kind of works is, I'll give you an example of that. We have to make measurements on our experimental rig. But if you've got cameras on your laptop pointing at the rig and you've got at least one person that's online, what we're going to have is any engineering team has roles. A good functioning team has different roles. And so you have a measurement engineer that's turning the knob on the dial and possibly reading an instantaneous value. But then we have a data engineer, and the data engineer is the person that's virtual. And the data engineer has to log that data and then put the plot or do the analysis that's actually workshop deliverable. And in any team scenario, because engineers work in teams, chemical engineers work with mechanical engineers, with materials engineers, engineers often work with teams. The key there is to communicate. And so in your workshop, where there'll be 15 teams, all on their own individual, all have their own rigs, they'll all be doing measurements, they're all going to have to be communicating to your group. So it might be a little loud, so you're going to have to figure out good ways to communicate to your group, because it's the data engineer that's actually going to help make the deliverable that allows you to get a mark in your workshop. So what we'll have is, there'll be some workshops all virtual, and then we'll have 6 that'll actually be in person. And all the information about when those happen is on Canvas. I keep talking about Canvas. When will I get there? I'm going to get to Canvas. So I'm going to jump out of PowerPoint. Well, walk, not jump. And oh no, here we are. I'm like, that's my email. So on your Canvas dashboard, which is our learning management system, when you log into it, it'll look a little bit like this, but you'll have different subjects. Like you might have maths, you could have calculus. You might have a chemical engineering, a community if you want to be part of one. I have the other subjects I'm teaching, like product development, but you'll have on the subject tab, engineering, technology, and society. And so then we'll have, hey, here's this great description, welcome, and there's a cute little banner. Now I'm going to put this in student view. which is not always as exciting, and it's a little slower because it's the view. They try to show the way you look at it. So after I put something up, I have to say, well, does it actually look like the way you would see it? So this is what you would see. You would see announcements. But the key part for next week is in modules. So we have a couple parts. We have announcements. And in fact, I just sent that announcement to everybody. We have subject overview. It's stuff out of the handbook. But then there's this cool section on subject delivery, assessment overview, key dates. So if you can't find anything, if you click subject delivery, it'll tell you about the schedule when we do different things. If you're going, well, gosh, where's my assessment? You can get the assessment overview if you're curious about that. But then when we get to modules, that's kind of where we stick everything that people need. We've got staff information, which means if you wanted to see, funny pictures of us, you can find them there. You can find out our staff contact details. The demonstrators will be up there. But in subject information, remote teaching. This link will get you to where you need to go. To get to the lectures next week, all you need to do is go to remote teaching, and at 11 o'clock on Tuesday, click that link. You'll get asked for the password through Zoom, and that's how you find your lecture. And there's a consultation session. And once you know which workshop you are, now remember, anybody can throw it in the chat. What week do workshops start? Is it week 1, week 2, week 3? 2, awesome. So week 2 is when workshops start, and you can find the link for your workshop as well here. So whichever workshop you're in, and you can tell by the time as well, you'll be able to find that. Now, what if I missed a lecture? No worries. All of that will be in, thank you. This is the problem with Student View. Your Student View will show up your lecture capture. And in addition, in modules, for a lot of our modules, I think I still have to, sorry, I'm still setting them up. But what'll happen is in week 1, if you want to find the slides from the overview slides I said from today, you can actually find all of those here. And so it'll take a second to download because it's a little slow, but you can find the full subject overview lecture and all the information I showed you today with even more you can find here. And so modules has an awful lot of information. Also in this module, you'll see installation instructions from MATLAB. MATLAB is, I'm going to just go back to modules for a second. MATLAB is, you can see there's introduction to MATLAB, installing it on your computer. MATLAB's a computer program we use. We'll certainly talk about it in detail next week. But for those of you that go, gosh, is there anything I can do to get ahead? You can install MATLAB if you want. Just follow the instructions for your computer. You have to make a MathWorks account and then have a question. But feel free to ask me about that later. And so I think that's where I want to wind it down for now. So where should I go, or what can I do? How do I find that first lecture? Go to remote teaching and click on that Zoom link, and you go, wait, what if I missed that information? Go to lecture capture, and you'll be able to find Tuesday's lecture. So, and you can rewatch sessions again and again and again. I don't know about this session, but I need to stop sharing my screen because while I mentioned what we do for ETS, and I talked for way too long, don't worry, I'll be much better timed in the lectures. Some of you, it might be crazy to think, but what if engineering goes well? Because we're kind of hoping it will. What if you go, engineering was so much fun, I want to take more engineering? What else? Wait, we learned about all these different types of engineering, but he said engineering's way too big for one subject. What do you do in second semester? So with that, I'm going to hand over to Gavin.
Thanks, Ray. So I've got a couple of slides here just to excite you about semester 2 after ETS. So I'll just pop this up on the screen here. Okay, so if you are keen on engineering and you enjoy ETS, we have something, I should say even more exciting, but let's say equally as exciting for semester 2, and it's called EMD, Engineering Modeling and Design. It's our second semester, first year subject. We have 3 projects that will run for a full semester. One is designing and programming an autonomous robot. Pretty cool, huh? Follows a line and picks up objects. One is designing and building an audio speaker system from scratch. So you'll be able to 3D print your speaker and assemble the magnets and everything. And one is modeling and simulating a coastal flooding scenario. So that's a simulation-based exercise, and then you're going to actually go and model that in a big fish tank with some cool cameras hanging above. And this really extends what you do in ETS, where now you have a bit more control over the projects. Okay, you learn things about working in teams and working on large projects in ETS and take it into EMD. We also have some exciting stuff coming up in semester 2. We have our creator space opening up. So here's a mock-up picture of what that looks like, and it will have all sorts of cool tools that you can use in there and get trained on to use for those projects. And I don't know why that says 2020. That's should be 2021. I keep forgetting we're in 2021. Lastly, we are going to offer a bunch of skills modules in semester 2 for EMD, and they're all project related or assessment related. So these are like these little cool modules you can choose to do as part of the subject and learn a bit, maybe a bit about the project, but maybe a bit outside the project. So we have things on Arduino, CAD, some analog electronics, but even things on making a short video, because we're going to get you to make a video in semester 2 about your project, a little fun exercise to show off to everyone else what you've done. Okay, so that's a very, very quick sneak peek of what's coming in semester 2. I'll pass back to Ray now, who's probably being buried with questions in the chat. Ray, you're on mute.
I am in the first workshop. So I already had somebody say, wait, the workshops look like they're online. How are they in person? And that's a great question. So 6 of the workshops will be simultaneously in person and online. So people will take those together. They're at the same timetable and they happen simultaneously. So, and the workshop, the online workshop will be broadcast from the in-person workshop. So everybody will be together. The first workshop in week 2 is virtual, and we'll go over the details about how the in-person ones will work, what you have to do to get on campus. And we'll also, in each workshop, we'll sign up who's coming in person, so we'll know who's going to be in person and who's going to be online. So let's see. So questions about software, I've seen a couple there. Remember MATLAB, which is free, which students get for free, we will be using. We'll also be, we do 3D printing in ETS as well as EMD. And so we're going to teach you how to draw an impeller for a pump and then 3D print it. The software we use is Inventor or Fusion 360. They're both Autodesk products. They're both free for students. We have installation instructions and cool instructional videos on how to draw in both of those software. So you can learn either one. The reason we do that is some people like Inventor, some people like Fusion 360, but the same company makes them, but Fusion 360 runs on a PC or a Mac. Inventor only runs on a PC. Let's see, everything else. Can you take EMD without taking ETS? Yes, you could, but I don't know why you'd want to. They're both fun. And the things you do in ETS, working in teams, learning how to use MATLAB, learning about 3D printing, as well as engineering problem solving, position you to get even more out of EMD. Because the better base you go into EMD, the more you're going to be able to achieve, because it's got such awesome open-ended problems to it. I don't recommend a Mac or a PC. I use a Mac. My colleagues use a PC. Right now, there's an optics software I'm using where I had to get a high precision virtual environment to use it as a PC. We'll go over some of the details about computers. There's quite a few things there. I'll show you there are virtual computers you can access as a student with My Uni apps. So don't run out and buy a computer in the next week. Let's go through next week, make an informed decision, see what your other subjects are like. And if you want to make that investment, maybe wait a week or two before you decide. No, you don't need a GPU to run MATLAB. I think there's a version of MATLAB that runs on an iPad. Can I rewatch this recording session? So if you have a class, as I said, you have to attend your workshops, but remember, they don't start till week 2. And the lectures, because there's 600 of you, we're not expecting everyone in the world may necessarily make every lecture. So they are recorded. They're available. The consultation times will be recorded. And if you still can't connect to a lecture, let us know, because we'll be setting office hours and there's consultation times. We will find ways to connect with you if you have questions, or just to connect with you. I mean, an awesome semester for me is where I get to talk to at least everybody once. Because there's in-person workshops this year, I can actually make some of the workshops as well, and I'll get to see people using their rigs, and I'll also jump in front of cameras and wave at people in the breakout rooms that are online as well. So that'll probably be a little disturbing, because, you know, anyway, I'll try to keep my distance from the camera. There was is there any extra equipment we need to buy for labs or practicals? No, we provide you safety glasses. It's just water. We're working with water. We work with a submersible pump. So it's actually designed that if it got wet, it was designed to be underwater, so no one gets electrocuted. And no, we provide goggles. There's some footwear requirements, like no thongs on workshop days, because you need your toes covered. Should anything fall on your toes, we'd like you to keep your toes. You don't want to get cut. The workshops start in week 2. What is the schedule for workshop slot in my timetable in week 1? So there's nothing. So you know what? In workshops don't happen in week 1. So you have 3 free hours. Go for a coffee, go outside. Exercise is always good. Connect with friends. Follow up about student clubs. And I will say this, the second week we will be talking about student clubs in lecture. You're going to see I've got links for every engineering student club. There's lots of virtual activities they're doing. So whatever your flavor of engineering is that you're interested in, there's actually a student society. We're going to have some of them in lecture, kind of a student club extravaganza. So you can start to connect to see, hey, if I'm interested in engineering, or I'm just looking for a free barbecue sometime this year, that there's a lot of possibilities there. Do we need to buy anything for textbooks for this subject? No, because remember, it's a design problem, and we're picking out the pieces of technical literature that we need at different times. So it's not a full textbook on any one topic. We have lots of suggested reading, but a lot of times what we also try to do is we try to pick textbooks or resources that are available virtually through the library. So that if you want to read a textbook, there are ones you could always go out and buy, but we might say, hey, here's a link to one that you can access for free through the library with your student email ID. And a lot of times that makes it a little easier. Is it fine to put workshops before? Is it fine to put workshops before lecture? Workshops are mandatory attendance, lectures are not. The information in lecture, kind of important to make sure you keep up with. Remember, lectures 1 week is the material in the workshop for the next. So however you're keeping up with your workshops, you want to do it on a weekly basis. Starting in week 2, I'll also have a weekly mailbag on Canvas as well, where it just kind of says, hey, look out for this, and this is going on this week, and these are the student events, and this is what you're going to be doing in the workshops. And I'll also tend to put announcements out as well, highlighting the weekly mailbag. And some of them are even video announcements, so it's like me talking in like a 2-minute snippet. So are there lecture slides available as of now, or only lecture 1 for now? So lecture 1 and 2 are up. Part of lecture 3 will be up. And then this weekend, I should put about the next 3 or 4 weeks of lecture slides should be up before the semester starts. There's pre-recorded videos, and I'm trying to fix a few of them, add music and add some quiz questions in them. So it's kind of like when you're watching standard Netflix where it says, are you still there? I'm trying to put that kind of prompt in the video, but it's like, you know, what's Reynolds' number? Are there typically active user limits for library ebooks? Most of them, no, because it's a subscription for the university. Are there differences between EMD and ETS? Heaps of differences. We're both about solving engineering problem solving, but you know, we're trying to give you different experiences in different semesters. It'd be boring if you just had the same thing twice. So we have kind of a semester-long design project that everybody does, and there's lots of chances for you to be individually creative there and have your own design. But EMD is much more about kind of honing in on one problem that maybe is a little bit more open-ended. So ETS is kind of like, well, people are just at uni, let's give them some breath so they can, and some structure to figure out how to get through university and how does engineering work. But then by the time you get to EMD, that's when the problem gets a little bit more open-ended. Gavin, did you want to add more on that?
Yeah, I think that's
I just had to unmute. Yeah, Ray, I think you covered that pretty well. EMD, you get then a choice of one of the 3 projects, and there's a bit less in the way of instruction. As I said in the chat, there's lectures for the subject, and it's more about the design problem and projecting what you've learned in ETS, but also what you're learning in EMD along the way. And then there's those optional skills modules. So you're a bit more in charge of your own learning in EMD.
Now, somebody said the ETS and EMD are not in the course plan. Actually, what you need to do is if you look at any of the engineering course plans through the engineering courses and even the science stuff, what you'll find is they're recommended subjects, just like your electives. The engineering subjects, if you want to be an engineer, this is the pathway to do it. We do give some students some flexibility in student choice. A lot of times that's around being flexible because people want to take an engineering subject and a coding subject. But by the way, there are other ways to do that as well. A lot of your course plans might say you need 6 breadth subjects, but you actually only need 4 breadth subjects and can have 2 science electives. So you can actually take the engineering subjects and the coding subject and still meet all your first year requirements. Can't hurt to stop one for some course advice just to make sure you're okay with that. There is a limit on how many 100 level subjects you can have in your degree, but you can actually take a coding subject and the engineering subjects in your first year, where one of them just counts as a science elective, because you only actually need you have to have a minimum of 4 breadth, but you can have up to 6. Okay. A lot of you, I'm so sorry we ran over. Thank you for hanging around. You may want to go to the next session. By all means, leave when you need to. We'll hang around for a few minutes if there's more questions, but thanks so much for coming along. And we'll see a lot of you on Tuesday, virtually via Zoom or recorded, but we'll see you. And remember, your workshops start week 2. Let's see. Right. To find all of the pages for, oops. If you don't know where Canvas is, there's the link for it. I should have put that up there. And this is recorded, so I assume Science is posting them. Gavin, I think they are. All right. Okay. I believe we're gonna finish up then. Oh, somebody asked about exams. The exams will be, our exam is online. It's actually using MATLAB Grader. And if students have time zone constraints, we accommodate that in their exam timetables. We don't make anybody take their exam at 3 in the morning or something like that. I want to take up MEng in software engineering. Is a good idea to take this subject? Well, I think so. We're going to talk about software. We're going to talk about a lot impeller design and 3D printing and fluid flow, and these are tenets of mechanical engineering. And then we're talking about image processing taught by someone who's actually a computer scientist by training. So I think it's really good foundations for the things you're interested in. If you're going in MEng in software engineering, not mechanical engineering. So yeah, I still think it's actually a fantastic introduction to the application of how software is used in a nice application. And image processing is kind of the simplest form of signal processing, which really is a big component of software engineering. Anyway, thanks so much for everybody being here. Thank you to Gavin, and thank you to Science for setting this up. I think